Here's problem number 13 from section 4.3. We are asked to find all the points of inflection for this curve. Let's go ahead and find the second derivative and see where those inflection points exist. The first derivative is going to be first times the derivative of the second plus the second times the derivative of the first, which is equal to x e to the x plus e to the x, which is equal to e to the x times the quantity x plus 1. It's important that we factor out the e to the x, as we're going to see in a second. Let's go ahead and find the second derivative. It's going to be first times the derivative of the second plus the second times the derivative of the first. And again, we want to factor out that e to the x, and what are we left with? Well, with this one plus the x plus 1, or e to the x times x plus 2. Now, inflection points are a place where the second derivative changes signs. Now, we look for possible places of inflection where the second derivative is equal to 0. This is never 0. E to the x is never 0, but x plus 2 is going to be equal to 0 when x is equal to negative 2. So what we have is y prime in a number line, and our spot of interest is negative 2. And if we try values larger than negative 2 in here, what we're going to get is positive values. If we try values lower than negative 2, we're going to end up with negative values. So at negative 2, we see that the second derivative does change signs. We need to find out what is the value of y when x is negative 2, and that's going to be negative 2 times e to the negative 2, or negative 2 over e squared, which means that the inflection point happens when x is negative 2 and y is negative 2 over e to the negative 2.